And maybe better if you share the presentation.
Tá bem. Bem, bom dia a todos. Hoje é dia 1º de maio de 2021. Estamos começando mais uma transmissão no FlexNav TV. E hoje é uma transmissão especial, transmissão de comemoração de 1 ano do canal. Como nós temos vários convidados internacionais, a transmissão hoje será em inglês. E vou aproveitar e começar apresentando aqui, dizendo para vocês que good morning, today is May 1, Works Day 2021. We have a lot of international guests here today, special guests. Today is a celebration day, 1 year of FlexNav TV channel, and we have to celebrate this day. And nobody better than these guys. These are our friends. We have today here our inspiration guy, Professor Francesco Maisano, directly from Milano now. I think that he's in Milano. He's in Tuscany today. Channel. Yes. And we have to celebrate this day. Mr. Andrea Guidotti, nobody. Thank you for your participation here. Marcio Taramasso. Great, Maurizio. Thank you for your participation here. And our panelists here. Hi. Adolfo from Cordoba, Argentina, our partner. Mohammad Sarraf from Rochester, but he's in Alabama today. And Ilan, my friend here from Rio de Janeiro. Thank you, Ilan. Thank you for your participation. And I think that this channel will search from some goals and to engage more people, to share some knowledge, and to bring us you for discuss some technique, some procedure, something to do in the interventional heart and structural. So, Gustavo, do you want to say something?
Just to thank all the participants of this session. It's really great to have this kind of experience with us, and I think we can start with Andrea, and may you share your presentation, and we can jump. I think Professor Maisano is having some issues with his connection, so we will start with Andrea. Is it possible?
No, it is better that, the best is that Andrea shares my presentation.
Oh, okay.
And I can start because I think my connection is not so good. So while Andrea, so Andrea, please share my presentation, and I can start already saying something while we wait for Andrea. I would like to say one important thing. Today, I don't know who is going to join this webinar, this live session. And for those who want to learn something specifically on some specific procedure, I already apologize. We will not learn a specific procedure, probably will not learn a specific tips and tricks. We will not learn how to deal with specific problems today. But today, we do something even more important. We talk about how do we learn, how we can learn from each other. And I think to me today is like the best way to recognize that what we have done in the last 5 years has not been for nothing. Being part of 4 valves today is the best demonstration that the seeds that we put into the ground a few years ago are growing and are making plants which are growing and becoming huge trees and becoming the next generation of education. So today the topic is about simulation-based training in general, in medicine. We will focus on structural intervention, but obviously this is going to be a trend which is going to be transversal in many other areas. And simulation is only one part of it. I'd like to make a call to discuss overall how do we educate the next generation? And the reasons, yeah, good. So that was probably something that for my generation is very well known. Maybe there is some younger generation, some millennial around. Maybe they don't know exactly what that means, but you know, the Wall was a musical which brought first time to the attention of the general public the issue of education. And the way we educate today probably needs to be revised. Let me tell you my perspective as a chairman, as a professor, as a whatever, as a doctor who wants to share his own experience to the rest of the community. You know, in training, we see a lot of people, a lot of young guys with huge potential, huge, talents. People with a lot of curiosity, a lot of ideas, and they start their training process. And then after a while, we shrink their potential, their curiosity into a job description. So imagine now the challenge we have ahead. Everybody here in this call is a good interventionist. We are all experts, more or less. And now that we are good, that we learned the job, now we have a duty to share what we learned to other people. The big issue is, how do we train the next generation? And the big issue is, what will be the job description of the interventionalist of the future? So I was confronted many times with this question: who will be the interventionalist of tomorrow? Well, this question is actually, you can really cut it in 2-3 pieces. Who will be means job description. Interventionalist means a definition. Tomorrow put us into the time perspective. Let's start with the first question, job description. And Andrea, let's go next. And next again. I make you the example of this question given to a cardiac surgeon. Well, a job description of a cardiac surgeon, you can define a cardiac surgeon. Most cardiac surgeons define themselves as those who can use a knife very well, those who have a lamp, some loops, and they use the Harlan machine. This job description has been working well for many years. Is it today the right job description? I really don't know, to be honest. What will be the new description next? Who will be the surgeon of tomorrow? I mean, everybody knows the surgeon of the past. Little eye, big lamp, big brain, smart guy. What's going to be next? Try next. Pick next. We don't know. Can be a mix of everything. And that is a problem. If we don't know the final product, the overall concept of the education is already being in trouble. Till now, the education system has been defined by a process where you take everybody with different tools, different backgrounds, different talents, you put them into a standardized process, and you print a system which is sustainable, standardized. You create everybody same. And in this process, you try to reduce the influence of creativity, the influence of the intelligence of each one of them, you really shrink people into a job description. Next. Basically, I was very impressed in Germany because in German, education is called Bildung, which is very similar to building. It's like you build something. To build something, you need a platform. You need to have a standard. You want to build something, you know what you need to build. Well, this is not anymore possible because the cycle of innovation is so fast that we cannot really predict what will be the job description of the operators of the future. Next. But basically, the main challenge we don't know the definition of the new interventionist. I was asked this question a number of times. They say, what do you think is going to be the intervention of the future? And my answer, my friends, is like this. Don't ask me. Why you ask me? I'm going to retire in 10 years. I don't know. You should ask the people in training, and you should ask the patients, because they will be driving the game in the future. Maybe I can answer as a patient, but not as a physician. So it's very difficult to think who is going to be the next interventionist, the next leader of the healthcare system. Again, when I do this discussion with surgeons, I try to tell them, forget about the knife. I mean, if you think that your job description is defined by a knife, you are lost. It's not anymore your future. You need to understand that competence is more important than technical skills. And this applies to everybody. It applies also to interventional cardiologists. Imagine the arrhythmologist. I'm not sure that in 10 years from now, we're going to use catheters to ablate. There will be probably some gamma knife system. So technical skills are not going to be forever. Things are changing. So the real point in the future is not to be skillful, is to be competent and to achieve those tools which will help you to become a leader in your team. It's going to be a team. And that's why, next. In my practice, I found out that mixing my skill set with other skill sets improved my possibility to help people to deliver a good healthcare. And obviously, as you expand your skills, you restrict your area of action. You focus on one or two diseases rather than span and use your skills, your tools across the full border of diseases. So you become from generalistic to very specialized. You understand one disease, A to Z, and you are very super specialized. As you get super specialized, you also become dependent on a team. You can't handle everybody. You need to work in teams. That's the big challenge of the future. We don't only have to understand and to learn who we are, but also we need to understand and learn how to work in teams. Next. And the next question is it tomorrow or it is today? This is the biggest question. Everybody thinks it's going to be tomorrow. Are we sure that this is the problem of tomorrow? Because next, in the last 15 years, we developed a huge amount of new devices. Today, we work with innovative devices, very different from the past. Next, we work with new imaging tools, which are showing us unexpected findings. We understand physiology and anatomy better than before. We work in new operating rooms. We work in a totally different setup. But we still teach the old way. That is the biggest challenge. Believe me, when I talk to the university, they say, yeah, good idea, but first we need to think about something else. Stupid. The real next innovation is going to be innovating in education. Just what you do on a daily basis. We need to innovate the way we educate. We still believe that education can be achieved by observing. Are you sure this is going to be the best way to learn? Particularly when you think about the time constriction that we have today, the society has changed, and there are many rules, many constraints. Imagine Denton Cooley was using to say next, see one, do one. Is it enough? By using this approach, obviously there was a challenge. This was a few years ago very clear. There was the so-called June effect on surgical mortality. As soon as the new round of fellows were coming into the operating room, the operative mortality was increasing because there was obviously a learning curve. The new fellows, the new residents were learning, and there were more complications. Next. This was very, very clear a few years ago, and this could be even more challenging in the years to come because of the huge amount of challenges we have ahead. For this reason, I strongly believe that simulation is the way to go. It's a bit strange to think about simulators because we all believe that simulators are similar to some video games. Next. Simulator is something that in some other areas where safety, standardization, training is important, is already established. In the airplane business, using simulators is standard practice. Next, exactly, the training simulator of airplanes, but also of other machines, is much better and much less expensive than the real thing. Next. Imagine that to fly a Swiss Air Force F-18 costs $33,000 per hour, while a simulator costs $500 an hour. I mean, the huge difference is also economical. Next. So we have been all together showing the value of simulation in the Hard Lab Zurich, at the Hyderabad meeting, at PCR London Valves, and so on. This is the next future that we need to establish and to incorporate in training education in the future. Next. The main point about simulation is not about learning the basics. It's about learning how to cope with unusual situations. Those situations that you will see probably once in your lifetime. This is where simulators plays an amazing role. And this is where we have to understand how to implement these tools in our standard practice. It's not only this one. Next, the simulators are also very useful. Good next, Andrea. The simulators are also very useful to get information from the expert users. There is a subconscious skill which is very difficult to teach. When you see a skillful teacher, a skillful opinion leader or let's say operator, you ask the person, how do you do this? And often you don't get the answer. And the reason is that we do things with talent and with subconscious learning, and we don't even know why we do like that. Using simulators and special skills, we can obviously improve the way to catch these tips and tricks from the best people. So in summary, simulation training, instruction interventions can be very useful because it can be done at different levels of sophistications, not only high-end technology, but also low, intermediate, and high fidelity. The students can learn a variety of skills without the need of intervention by experts, and most importantly, by preventing harm for the patients. We don't do any more training on animals, and really, the future probably will have no animal training anymore. With simulators, we can simulate scenarios, different scenarios, specifically those scenarios which are not usual, which are maybe happening once in your lifetime. They're also useful for team building. Very important. It's not only single operator training. The simulator help to build the teamwork. Next. As I told you, you can train rare complications. Next. You can understand unconscious teaching and learning. And therefore, the simulator is going to become a major part of our future educational pathway. And I'm very happy to have Simulands on our side. Simulands, which is also another stem of the activities in Zurich, because when we started, there was not such a startup, but having a startup on education is the best evidence that innovation goes through education. Thanks a lot.
Thank you, Professor Maisano. So I think that we can do some questions now, Gustavo. What do you think now?
I think so. Does anyone has a question?
Anyone from the panelists? Mohammad, Ilan, Adolfo?
João just got in.
João's here, yes.
João, welcome.
João.
Pearls of wisdom, as always, Professor Maisano. I think this is exactly what as you said, not the future, but today holds. And simulation is something that I believe that we've always done it, even throughout in the last 20, 30 years. Many surgeons started learning how to do, for example, cholecystectomy on an animal instead of a patient in the first case. But the other impact of, I think, simulation that we have to focus more is that we oftentimes use the words learning and training and education as if that they are equivalent of each other, but there are also different aspects of them. I think what simulation does is that it helps to not only train, but also sometimes it can even educate the person who's in training process. And those aspects should also be very carefully impacted. And one last thing, in my opinion, is that we are probably one of the last major industries in the world that is trying to appreciate the value of simulation. If you look at for example, U.S. military, they have a huge investment, and this is nothing new. It has been going on for over 2 decades. They've been focusing a lot on video games. A lot of people try to downplay the importance of simulation as if it's a video game. So what if it's a video game? Many pilots every pilot, even every seasoned pilot who's been flying for over 20 years, they still have to go through simulation training every 9 months for unusual circumstances. A number of years ago, I don't know if you recall, but there was a U.S. Airways at the time when U.S. Airways was still an airline that had to land on Hudson River. And in less than 2 minutes, they were able to evacuate the airplane, and no one really died. No one was even injured. And this did not happen just by play of chance, because every few months they go through this very sophisticated training, which is basically based on simulation. And that's why when the real thing happened, which how many times does it happen that the burst can basically shut off both engines at the same time? And within 2 minutes, everybody was saved. It was just because of the value of simulation. So I cannot really agree more, and I cannot emphasize more on the future, which is already here, which is today.
Adolfo, Maurizio, Ilan, any comment?
Maybe it would be very interesting if we ask Francesco to talk about his experience through.
In terms of simulation, as an imager, it does, now mostly CT and MR, but did a lot of TEEs. In terms of simulation of day-to activities that take place during, for example, a procedure, models that have been developed, at least the ones that I've had the chance to be part of, have not been extremely realistic, and that's what I would be very curious to see what Simulands have done. I recall one simulation I would took part when I was doing the neocord, and that was like a really sophisticated, wet lab with pulse pilot, because there's a lot of nuances that one is required to teach that procedure, as very well said. They're not only the cognitive aspects of recognizing the fluoroscopy of the hands, but also the interaction with the operator. And that duo is hard to simulate, but not impossible. Like yesterday, I was, at the Medtronic PRL, which I think that Francesco and Marcio have been there, and we're training with some novel therapy. And they had an echocardiography simulator, which was so inferior. I was like, wow, we are far from, what we truly need for this. And that was my candid feedback. So, I think we need to improve into at least echocardiographic simulation, particularly TE, and the dynamism as the procedure takes place.
It's a good point, Joao. I think you will see now probably the presentation from Andrea. But one thing is for sure, you can't expect from simulators to be totally realistic. I don't think there is one simulator which really fills the gap between the unknown and the practice. You don't have to think about, it's just like, if you are a master of Call of Duty, I don't think you're going to be good to go to Afghanistan, because in Call of Duty, if you die, you can't survive. If you go to Afghanistan and you die, you die. So there is no such a simulator which really simulates the reality. On the other hand, I agree with you that there are some simulators which are close to a video game, and they can be used. Some others where you can improve your imaging expertise. Some others where you learn how to work in team. So the recipe is to be able to use different platforms to train different skills and competencies.
Okay.
I think Adolfo was making a question as well.
Oh, I would like to,
or Gustavo, I don't remember.
I want to know two things. One could be your experience building simulator. What are the difficulties? We as a physician to try to train or to give an advice for the engineers to build the simulator itself, the money you need to build the machine, which is the main problem to develop a good of this equipment. And the other things I would like to say to Joao, if you pay attention to this June effect, what you want to train people is the basic things. When they know the basic and moderate things, you can prevent all the mistakes. Then, of course, you have to specialize, and you need the real life. But if you know the basic and the moderate things, you are in other level. You are secured for doing procedure. And Professor, can you talk about your experience?
So Adolfo, I start from the second point. I think to abolish the June effect, you need to couple simulation training to simulation certification. I mean, you need to certify skills. If you want to cut the learning curve, it's not enough to train, but also you need to verify that the trainee has been able to understand and to avoid mistakes. So this is something we need to work on. As far as the first question is, it's not easy, but also it's not that difficult to build a simulator, in the sense that in our experience, and I think Andrea can confirm that, the simulation business has not been an invention. We have been confronted with simulators in a stepwise fashion. We have been developing new ideas initially in animals. This was very expensive and time consuming. Then we thought, okay, let's make a simple simulator to do the proof of concept. Initially, this was maybe an ex vivo heart pressurized under Arcan machine. But then we moved to a more simple plastic 3D print and so on. And lately, something more sophisticated, maybe pressurized again, and silicon model with some motion. And after you make the simulator for the proof of concept, then you start developing the device, and through the R&D process, you have to use different simulators, and then you test the simulator. You test the procedure before you go first in man, and after you clarify the procedure, then you have to train physicians, and then you build the simulator. So the simulator doesn't come out of the blue; comes from a process which has been highly integrated with simulation-based R&D first, and training after. I did the first in man cardiovalve a few weeks ago, and it was amazing experience. We had a simulator, and the day before I had a 3D print of the heart of this patient, and I implanted on this 3D print more than 10 times, almost 20 times, I think. And the first 3 implants were a failure. I made mistakes because the delivery system was not ready, and so I had to understand the little details. After the 3rd implant, I was able to perform the implant as intended, and after the 4th, the 5th, it became reliable. After the 10th, I became bored. It was boring. I said to my engineers, I want to be bored. Once I am boring myself doing the procedure, I think I'm ready. And so the day after, I did my first in-man, but that was not the first in-man. That was the 21st procedure in my background. So that's the key element. It's very simple. We don't have to make a philosophy out of it.
If I may say something here,
you have a realistic simulator, then you have an advantage that you are not improvising. Yes.
Okay, Mohammad, sorry, we need to move on because the hour is going on.
Sure, yeah.
And you can ask after. Before the presentation of Andrea, Pedro?
We'll play a fast video from Simulands.
Yes,
Pedro?
yes. You put a video about Simulands before? Okay, great. Yes, the video was in the big screen in the YouTube. Okay, and now, yeah.
So
Andrea?
yes, while Andrea is putting while Andrea is putting his presentation, Francesco, Esteban, it's on our chat asking if there is any metrics to measure this evolution of trainment when you're using a pre and post training with a simulator. Do you have any data about this?
So,
you and Andrea,
so there is maybe. There have been a number of publications on using metrics for learning. We have done some experiment in Zurich using different, let's say, objective measurements like eye tracking and timings and so on. So yes, you can measure skills, but I believe this is still something we need to learn. For the time being, the simulator should be used, in my opinion, still as a fake patient. We don't have these metrics, but I have been using simulators to assess the skills of my team, for instance, for ECMO simulation. And those who were not able to implant an ECMO system were not allowed to do it on patients. So at the moment, there is no metrics, but I assume we are working on that, and I'm sure that we will get these metrics. There are some, if you take many simulators, they have some metrics, but these are not enough to finally conclude that somebody has skills and somebody has not, in my opinion.
Okay. Andrea?
Yes, excellent. So my name is Andrea Guidotti. And today in this presentation, I'm going to show you how Simulands and we at Simulands are innovating the structural intervention arena with the innovative, new, modern education and training tools. So, I like to start from our goal, if you want, the mission of everyone of us in this room, that is provide patients a better outcome. And it's proven that the outcome of any procedure is linked to the skills of the operator in performing that procedure. The example here of the mitral clip therapy in a multi-center study show how the skills of the operator are linked to those outcomes, and the outcome get better after 50 procedure and then to a plateau after 200 procedure. So what if you are the first patient treated by a new operator on a specific procedure? That patient most probably will potentially get a worse outcome than patient number 50, patient number 100, patient number 200. How to solve this? We are talking about a learning curve. Animals have been used since many years in trying to fill this gap with implications which are ethical for the animals, which are cost driven and related. Also the fact that animals are different from humans. And so I tried to do a procedure to treat an animal, but then the situation, the setting, the anatomy in the patient will be different. So I will never be able to really fill that gap. Exists a number of simulators. We talk about virtual simulator, or somebody of you call it video games, or exists also hardware simulator that tend to be a silicon replica of a CT scan of a patient. These tend to be inefficient solution because they don't consider the entire procedure. They don't consider the images. They don't consider the device interaction with the anatomy. They just want to be a representation of the anatomy. And in this direction, Star Simulands wanted to bring innovation in R&D of new devices, in training, in education, all along the innovation cycle of a new therapy, from when you have an idea and you want to do a first bench test, and then you start the preclinical work and you want to define the procedure, and then the first cases, and then you start to enter into the market up to full expansion, and you need to train and retrain a physician. Francesco put well the setting of why there is a need of a revolution in education, revolution in training. That is basically why we need to innovate this field. And with Simulands and with our toolkit, our goal is exactly to address the learning curve issue of a new therapy when in the cath lab with the new operator. So how to improve the procedural outcome, how to accelerate the skill learning of a new operator. It's just enough that the operator will do the initial cases on a simulator and not on a patient, because this is the reality today. Many times the operator really get into learning those skills only when to enter in the cath lab, only when a patient is on the table. So the suboptimal outcome we saw in the presentation before of patient 1, 2, or 50, those could be avoided having initial advancement of the learning curve using simulator platform, so that after doing 10, 20 cases on a simulator, your skill will be ready. You will be ready. And you will go in the cath lab providing your patient with a better procedure, a better outcome, and the patient then will benefit from this procedure. In building our simulators, we start looking for what the requirements are telling us. In the same way, is very regulated the development and the validation of new devices before to enter into the market. We use and we apply the same ISO regulations to build our simulators. In the same way, there could be a medical device. So we are sure that when you train your procedure in our simulator, we are providing you a human-grade platform, the closest setting to what is a human setting, your patient setting. The point that the simulator can be CE-marked, can be used and for R&D validation of new devices as well. And it's important to underline which are the pillars of our platform. We produce a real simulator that you can touch, where you can use a real device, the same device you're going to use in your patient. Our simulators start from real patient imagery. CT scan, MRI, 3D echo are used to create the same, not only geometry, but also anatomy, movement, and everything is considered in order to create the most realistic interaction of the real device with the anatomy that we have created with the simulator. So friction, haptic feedback, but also anatomical setting can be variated inside the simulator, so you can train on a standard anatomy, on more advanced anatomy, or even in a troubleshooting situation. And most importantly as well, imaging. You can follow the procedure on the simulator using the integrated camera, which will replicate the usual echo or fluoroscopic images that you tend to use during the procedure. So when you will go in a cath lab, you will be used to look for those images. As well, the simulator being ultra portable and metal free can be used in a cath lab. So you can use under fluoroscopy or with a real echocardiographic machine. Intracardiac, transthoracic, transesophageal. So everything will help to fill the gap from when you have in your hand for the first time a new device and when you will have to go in a cath lab to treat your patient. We really start from the imaging of patients which are indicated for a certain procedure. Today you will see a live in a box where a transcatheter aortic valve implantation is performed. And we start from a patient indicated to be treated for aortic valve replacement in a transcatheter way. We use CT scan, MRI to validate the movement of the structure, how they should expand the compliance, and 3D echo to characterize the soft tissue like the valve leaflets. We create a 3D model that then we process and mix in multiple additive manufacturing technique. We create a model that can be human grade and can help you in learn all the steps of the procedure. Then again, better treat your patient. You see here a comparison between a simulated use implantation of the aortic valve prosthesis and the real patient implantation. We have built upon these pillars three categories of simulators that we call simuDry, simuSlice, and simuPULSE. And this categorization of the simulator is really meant starting from which are the needs of an operator today that want to learn a new procedure. The first thing, you need to learn the basic skills. You need to learn how to touch the device, how to maneuver the device, where to take the handle, what this knob is for. And the simuDry platform that you see in the first column here are meant to address this specific need. Moving then to the simuSlice, where within an aquarium, the simulator can be used under real images. And you can perform the entire procedure, so to have a full procedural training, not only of the operator, but also of the imager, that can use a real echocardiographic probe to guide the implanter in doing the procedure. Up to the simuPULSE category, where a beating heart simulator is created to replicate a very close replica of what is the human setting. So we have hemodynamic, we have a beating heart, and all the structure and the interaction from the access point, from the groin up to the target area are replicated, moving towards high fidelity and human grade tools. You see, this is an image of the simuDry simulator, our essential simulator, and then the simuSlice, the second category that you can use under direct vision with the camera, which replicate the usual view by Caval and other views, but also under echo images. These are the images collected on this tricuspid simulator, which has been designed for the transcatheter valve repair technology. And then you can really feel better to go to a patient having learned these skills in something, in a platform very close to the human experience. Up to the pulsatile simulator, you will see it in action in the Live in a Box in a few minutes. But it's not all only about simulators. Here is about innovating training, innovating education. And simulators are one component of the toolkit that we propose. You know well the 10,000 hour rule. If you practice for 10,000 hours, you will master any skill. But 10,000 hours is a lot of time. It's 3 hours a day for 3,333 days. What if there could be a better way, an easier way, a faster way to learn new skills, to master new skills, to become an expert? And this is entirely possible. We believe that this is possible following few principles. You have to break it down, what you want to learn, in pieces that you can really account for, you can learn. You need to remove the barriers, and in this COVID era, it's not always easy to have a proctor or an expert coming near you and teaching. And you need to get guidance to help you improve and to let you to learn by yourself what you can improve, when you can improve. And here is where simu training and simu vision come into a play. Simu training is a educational content material that can really enable how you use the simulator to learn your skills. And it's structured in different levels of modules that you can go through and learn depending on where you are during your training development. From a beginner, a junior interventional cardiologist surgeon that want to learn structural intervention, up to experience, up to advanced training. And you can plug in, you can bolt on those modules to learn more and more. Breaking down the big elephant in small pieces that you can really address and master. And SimuVision, that is the next frontier, bringing our hardware simulator, where you can use real images, real device, into a new dimension, into an immersive experience, where with the use of augmented reality glasses, you can project over the simulator an holographic cath lab, having all the imaging in front of you, all the steps of the procedure in front of you, and being able to remotely connect with a product of over 5G on the other side of the planet that can guide you, or with an expert. And also, what Francesco mentioned at the end of his lecture, having tools inside that can monitor what you're doing. Your hands, your eyes can understand what you're doing and will be able to guide you on the next step of the procedure and of your learning experience. So with this toolkit, our mission is to revolutionize how training and education is done in our structural intervention world. And I'd like to thank you, and we can move to the next session where you can see this toolkit and our platform in use and in action.
Wonderful, Andrea. Just a question. You have simulators currently. You have the mitral, the tricuspid, and the aortic. That's it?
We have a few more.
Would you tell us?
Yes, I can go back to the overview slide. So we have developed a number of simulators for the dry category for transeptal puncture, tricuspid valve repair technology, mitral valve repair technologies. And then in the slides again, tricuspid technology under imaging guidance, but also LAA. And we have the mitral simulator and the aortic simulator in the pulsatile category. And we are continuing improving and creating new platforms to address the entire structural intervention portfolio and beyond.
Fantastic.
Great. Fantastic. Yes. Any question from Andrea? Ilan, do you want to say something? Mohammad? Ilan?
Yes. I'm, if I may, I was really very, very impressed from what I've seen so far. It's really amazing to see how we have advanced in this field of training. I'm very curious on how can we provide these better tools or wonderful tools of training for less advanced societies, that really need them the most, right? That have worse education systems. Maybe one area that we can pursue would be to do, instead of real simulators, do virtual simulators that you can, for instance, like a video game, play in your house and not necessarily needing to be in a cath lab or a simulated cath lab. I am really, really impressed, and I think this is really an amazing way to save lives, because in the end we're just saving lives. You are minimizing complications, and the economics of it need to be understood in order to make it work, right? Because right now it's cheaper to not to do that and just go on and deal with the patients like poor countries do. So it would be very interesting to see what we can do.
All good inputs, thanks. Obviously can look cheaper, but on the long-term complication and the patient outcome can have a big impact. To your comment on the availability of these new technologies, I like to stress that you are training here for something serious, for saving patient lives. And we stress the importance of being able to use the same device that you will use in your patient, the same imaging, to have very similar haptic feedback that are real, made of the interaction from the real device with the real structure, that are at the base of our simulator and can prove to provide better outcome. And to provide those simulators to everybody, we are partnering with big medtech players. I give you the example of the LATAM region. We have some simuPULSE Aortic simulator that you will see in the video with Abbott structural art, which are available for the region, and Abbott structural art within their training program is using to make these new technologies in training available to everybody which is interested in learning new technology and starting new structural intervention programs.
Okay. Mohammad, Francesco?
Yeah,
Marcio, I think I would like to answer also from a different perspective. I think virtual simulators, computer simulators are also one interesting component of the portfolio. But there is a huge difference between a virtual simulator and a real simulator. First of all,
yes,
a real simulator, you can use it with any different device, and you have tactile feedback. You play in the cath lab, you play as a team with real tools, with real wires. I mean, you really simulate exactly the same procedure. When you work on a virtual simulator, as you said, it's a bit more like a video game. And,
it's not real. It's not real.
It is also useful. But once you do it 3 times, you know how to cheat the simulator,
yes,
and you get what you want by cheating. It's completely different. So I have a doubt that this is going to be really the thing that's going to change our learning curve. I mean, again, we use the simulators also to improve teamwork, and this is not something you can do with virtual simulators.
Okay, Mohammad, last question.
Sure. So basically, I wanted to combine what Dr. Cavalcante and Dr. Gottlieb mentioned together. So first of all, we have to understand that simulators will never, ever, no matter how advanced the technology will become, even in 100 years, probably will never replace the value of direct patient care. So first things first. So we have to understand the limitations. But as Andrea mentioned, it really abrogates and reduces the number of complications, and also reduces the cost, because we oftentimes talk about the cost of the simulator, but we never talk about the cost of one major bleeding, one major pericardial effusion that ends up in the OR. But one thing that I wanted to mention, I think this is the Achilles heel of simulators, and it seems that Simulands may be very close to overcoming solving the problem of that Achilles heel, is that when you look at the smartphones, and the reason I know that is that my brother was peripherally involved in working directly with Steve Jobs when he introduced a smartphone in 2008 with AT&T. It was not the first one. iPhone was not the first smartphone that came into market, but the difference between iPhone and the reason that it took over the planet overnight was that before iPhone, you had Nokia, you had BlackBerry. The problem with those were business centric. So the phone came with a number of apps on it, and if you wanted to use BlackBerry, you only could do these things. iPhone, instead of being business focused or business centric, was a platform centric, meaning that you could be in your house coming up with an idea. I want to come up with an app for SDS calculation. I want to come up with an app for gaming, for whatever. And you could download it on iPhone. So it's so versatile that anybody can use it. I think the future of simulation should be something that I come up with a platform that if I want to do a microclip, a Pascal, a cardio valve, a cardio band on tricuspid, an LA closure, no matter what it is, all I have to do is I have to download these series of softwares, and I have to basically ask the permission from this medtech or that major corporation, and there you go. And I think when we get to that point that it becomes versatile, and of course, as Andrea mentioned, it has to be realistic, especially the device-patient interaction or device simulator interaction, then that's the point that it will take over the market. And one of the reasons that I believe that simulation has not come into medical industry is that when I say we, all of us as healthcare professionals, from MDs, non-MDs, nurses, whoever, PhDs, we have not taken the decision to generate the market for it. Once the market is generated, there will be tens of billions of dollars being poured into this.
Okay. Yes.
João, Adolfo, Maurizio, any question?
I think that we should move on, Gustavo, because
sure.
The time is going on. And Maurizio, let's now present in your Live in a Box, your case. Do you want to say something before?
I would like just to thank you for the invitation, first of all. And I think that the demonstration that we will see now is a nice demonstration on how the simulator can help. The concept, but I don't want to waste time because I think it's better to see it. But I really enjoyed one of the last slide of Andrea, where he showed the concept that simulation and training with simulation can be helpful in different levels. So you can use simulation training for beginner, student. They can understand anatomy. They can understand how to move a device posterior, anterior. And then you can use it for really advanced operator, for example, to train interaction in team, how to do, for example, tendine in a typical example where simulation is a typical team intervention where the interaction of the operator is fundamental. And then you can train experience. So this different usage on a different level, I think, is something that only this kind of physics simulator can give you. And then repetition make the perfection. It's like a music player. When you want to become perfect, you are a music player. You have to try, I don't know if 10,000 hours, as Andrea said. I didn't know this rule. But like for sure, if you can practice these 10,000 hours on a simulator, and then, repetition make the perfection. You know, this is the only way to get close to this automatism that then let you concentrate during the procedure on other more important step than to go anterior, I should move clockwise or counterclockwise. This should be acquired on the simulator, not on the patient. And I think we can then look at this. We did a Tavi implantation few days ago on the pulsatile simulator of aortic stenosis, let's say, of Tavi implantation. And
I think that now you can see the video, how Simulands works. Yes?
This is a short introduction. Francesco, if you want to go briefly over it, and then we will share the video.
So let's go fast. So that's next. You know, this is to answer some of the questions that, when you see these virtual simulators, you think like, be very careful. Most of the virtual simulators are developed together with the vendors. So this is the difference between the advertisement and the real thing. Let's go next. And next.
Orange man.
Yeah, I mean, that's the point. I mean, you think that and I tell you, I was there 10 years ago in front of a simulator. I thought I could do PCI because I was able to do it on a simulator, but it's not exactly the same. There are a lot of different things. There is a lot of manuality, a lot of little feelings you need to develop in all respects. And, you also have to suffer and to fail. And the failure in a virtual simulator will be a warning sign. In a physical simulator will be a real failure. You see something going really wrong. Next. So this is exactly the point. This is the way we learn procedures today. This basically is a must in the industry. Before you can do a procedure, I just got trained in implanting. AVP3, now Abbott wants me to go into learning webinar where I didn't learn anything. But anyhow, I have this webinar, so I pass the questions, and then the next step is to learn on the patient. And, this is totally stupid. It's not going to happen like this. So usually we use proctors, we use friends, we use... hopefully friends and proctors, otherwise you train yourself and you have a lot of problems. So that's why we believe that simulation-based training can be very helpful, not only to learn the fundamentals of the procedures, like Maurizio was mentioning. Simulators are useful for basic training, for device training, but also to train and retrain experienced operators to tackle complex situations and rare complications, just like the landing on the Hudson River. So with this, I think we should go and see what is the real advantage of using a real simulator. With Maurizio was there a few days ago in an animal lab. And by the way, the animal labs are not seeing animals anymore. We use simulators. So let's see the video. And Maurizio, you should comment on that.
Okay, great. Then in the next 22 minutes, let's watch the video from Simulands. Pedro, can you put the video, please?
Hi everybody, my name is Maurizio Taramasso, and I would like to welcome you at this session for the fourth Valves TV, which is gonna based on simulation training. Actually, the title of the session is Simulands session, and what we are going to do, we are going to explore the advantages of simulation training to prepare young operator, but also more experienced operator, to train them to perform some structural procedure. In particular, today we will focus on Tavi. We are going to use a simulator to implant a Tavi platform. We are going to implant a Portico, Abbott with FlexNav system Tavi implantation in this simulator. Let's have a look to the simulator first. The simulator that we are going to use today, which has been provided by Simulands, is a human-grade simulator which allows the operator to perform the different steps of the procedure all the way from A to Z, or also some single step if you want to perform and focus on only one single step of the procedure, by using real imaging. We have the fluoroscopy, we have some camera, and allows us to check the step of the valve implantation. Is a physical simulator based on a real patient anatomy that allows the operator to have a real haptic feedback and tactile feedback as well during all the steps of the procedure. This is the box. We already assembled the simulator. It's really easy to transport, so it's a portable simulator, can be assembled in a few minutes. There is just some water inside. There is here a generator which is inducing the pulsatility of the simulator, of the heart. You see the valve is opening and closing due to this generator. And this generator can also be modulated in order to change the the heart rate now is fixed on 60, but we can do rapid pacing, we can simulate bradycardia, we can simulate fast pacing, we can basically change the heart rate. Here you see the heart, which is angulated in anatomical position. There is the aortic arch. This specific anatomy is a standard one, but this can be changed. All the angle can be changed. We can simulate horizontal aorta. We can simulate acute aortic arch. We can simulate, ideally, any kind of anatomy. We can simulate also any kind of aortic anatomy, not only, let's say, heart anatomy, and also femoral anatomy. Here you see, this is a simulator for transfemoral access, can be potentially adapted also to alternative access, but today we are going to explore how to perform transfemoral Tavi in this simulator. There are two axes. One is the therapeutic axis, which is the right one in this case. One is the diagnostic axis, that is going to be the left one. As I told you, there are two cameras. Also, the position of the camera can be adapted. So if you want to check, for example, some other angulation, or if you want to check the cross of the delivery system through the arch or whatever, we can change the position of the camera. I think these are the most important features of the simulator. And next step is start from the beginning and perform the procedure. I already put the two sheaths in femoral position, so we are not going to simulate the puncture that in case can be simulated as well. It can be implemented with also ultrasound in order to simulate ultrasound-guided puncture if needed. And the first step that we are going to perform is to put the pigtail in the non-coronary cusp, like in a regular Tavi procedure. Let's start by putting the pigtail in the non-coronary cusp. Can we move the fluoroscopy on the table? Now, as you can see, the C-arm is in position. So from now to going on, we can actually act as in a normal hybrid room. We can inject contrast, we can use fluoroscopy, and all what you usually perform during Tavi can be perfectly replicated here. Under fluoroscopy, I am just now advancing a pigtail in the non-coronary cusp. Now the pigtail is exactly at the nadir of the non-coronary cusp. I just do some injection to check it. Perfect. We are ready to go. In reality now we would administrate heparin. Here is a simulator, so we don't administrate heparin. This is the only difference between reality and simulator, because we don't need heparin in this simulator. And now, next step, we are going to cross the valve. One of the advantages of this simulator is, you see, I am alone. Obviously, I have to do everything myself, but you don't need an assistant to perform the procedure here. So you can decide whether you want to train in couple, in two, so you can also simulate the interaction of the two operators during the procedure, or if you are alone, you can train yourself alone. You don't need a partner necessarily to train yourself. Okay, let's now cross the valve. Okay, the catheter that we standardly use to cross the valve is an Amplatz left 1. Now I remove the wire and I go with the straight wire. Alternatively, you can select which degree of calcification to have in your valve. There are different models of valve. This is a heavily calcified valve, so most likely it's going to be difficult to cross. But according to the anatomy, you can select also which wire to use. In this case, I try first with a regular emerald straight tip wire. Otherwise, like in reality, you switch to a hydrophilic wire, like a Terumo straight tip wire. Ready? Okay, now we cross the valve. We go slightly RO with the C-arm. Okay. We prolapse the catheter in the left ventricle, which is small. This is remember, is a real ventricle from a real anatomy, so the ventricle is small and hypertrophic. We now go for a long wire to exchange. Now we put the pigtail in the left ventricle. We check that the position of our wire is okay, and then we will put a stiff wire in order to be ready to perform pre-dilatation first. Because as I told you, with this simulator you can really simulate all the steps of the procedure. And in this case, since it is an evenly calcified valve, we want to do balloon pre-dilatation. In this case, I use a Amplat super stiff wire. I made myself the curve. You can use any stiff wire actually. I recommend you to use pre-shaped wire if you have it. If not, you can do the curve yourself, obviously, like in this case. Do a small curve because it's a small ventricle. We position the stiff wire in the ventricle. We stay in RO. Voila. And then we remove the pigtail. Now we are ready to perform the balloon pre-dilatation. Pigtail is still in the correct position. And now you will see how to change the heart rate. We will do also rapid pacing. Now we advance the balloon. You see there are the two markers, exactly like in reality. We want to be at the annular level with one marker in the ventricle and one above. Let's check the position. We are nicely 50% in the aorta, 50% in the ventricle. So I think we can now activate rapid pacing. Usually we do 180. Pacing on. You see now the heartbeat is increasing. We perform the balloon valvuloplasty, go down, pacing off. Exactly like in reality. We can now remove the balloon. Patient is stable. And now we are ready to move forward with the valve implantation. As I told you before, we are going to implant a Portico valve with the FlexNav system. So we are going to implant sheethless. We don't need any sheet to implant this valve. So now I remove the sheath from the right femoral groin. And then we insert with the integrated sheath the system sheetless. This is the integrated sheet to the FlexNav system. I made it wet in order to be really hydrophilic. Now the system is in. I advance the valve. There is no need to check the crimping of the valve fluoroscopically. And I go at the annular level. I check the position of the pigtail, which should be still okay. Yes. And now what I want to do, I modify the position of the C-arm in order to eliminate any parallax. So can you go LEO? You see, now we are perfectly coaxial to the Portico valve. And this is the perfect starting position. So we have no parallax. We know that we are exactly at the annular level. Before doing the implantation, before starting, I do another check. You see, we are exactly at the annular level. I like to start in this position. Now look at my hand. Actually, this is a two-operator maneuver, but it's so easy that I can do it also alone. It's really important to go really slow. You will appreciate how stable is the Portico within the FlexNav system. I can start the first part quite fast until the valve is going out from the sheath. Now the first millimeter of the valve are outside the shaft, and I wait a few seconds, usually 10 to 20 seconds, because I want the nitinol to warm up. After this 10 to 20 seconds, I will progressive open the valve extremely slow, one turn, and then wait some seconds. Maybe we go a bit more LEO. I think we have again some parallax. Left, like this, perfect. See, we may have to correct the position of the C-arm during the implant, because we want really to abolish the parallax, because parallax is enemy of the precision, and you want to be really precise. I see I'm opening really slow. If the valve is moving too much, we may need for fast spacing, something like 120, 130. In this case, it's really stable. And I have to say that in the majority of the case, also in reality, the implant is really stable. I proceed with the implantation really slow. One turn, and I wait some second. One more turn, and I wait. Look how the valve is stable. It's really not diving. This is the main advantage of FlexNav. Look also how realistic the fluoroscopic picture is. Like in reality, we can even see the calcific leaflet moving together with the valve. At any time, you can do some injection. I think we have a good height. We can implant even higher, but I think I will proceed like this. I like this implantation high. I have a nice contact with the non-coronary cusp. I try to go a bit higher because I like to implant really high, like this. And then I move forward until I get contact on the other part. I have no parallax, which I like. I centralize a bit the system, like this. I want to be without any tension in the mid of the ascending aorta. You can see in the camera that the valve is already opening now. Obviously, we have no complete flow, but the patient is stable. You see there is flow. The valve is opening and closing. And now I move forward really slowly. Now I got contact on the left coronary cusp. You see the valve is moving together with the heart. And I move really slowly until the stop, which comes out automatically. You see this bottom is coming out, and I can go until the click, which is now. Now the valve is functioning. This is the moment to decide, the patient is stable, to decide whether to move forward or to recapture. The best way to do it is to eliminate the parallax. We don't have parallax in this case, and to perform an injection. This will tell us, I don't judge whether there is paravalvular leak now. What I want to judge is the height of the implant, and then to decide whether to stay here, go higher, or go deeper. So, position or recapture and reposition. Let's perform an angiogram. I think the high is perfect. You see there is some tiny leak, which is normal at this stage. Again, here we want to assess the height of the implant. And in my opinion, here is 2 millimeters, something like that. So it's really ideal, 2 to 3 millimeters. So I move forward. I push on the button. Otherwise, I cannot move forward. This is a safety mechanism that prevents me to deploy the valve. You see, without any tension on the system, I proceed really slow. I can still fully recapture the valve if I want now. It is not needed in this case. I don't remove the pigtail. I want to have the pigtail until the real end in position because I want to have the reference. And now the retaining tabs is releasing 1, 2 are for sure out, and now also the third one. I can go until the end now. I have to check that all 3 are detached, but I already see that all 3 are detached. So I can retract the wire in order to centralize the nose cone and remove the system in the descending aorta. We can come back to anteroposterior now. In the descending aorta, we recapture the nose cone. We resheath the nose cone. Now the wire is still across the valve. You see the wire is keeping one leaflet open. So in order to have a proper evaluation, I remove the wire now. And then really carefully, I remove also the pigtail. This valve is really easy to cross again. If we want to recross, because we want to do post-dilatation, it's gonna really easy. In order to be really didactic, I use a wire to remove the pigtail, even if it is not required. You are not gonna embolize the valve with the pigtail. But in order to be safe, I put a wire and remove the jailed pigtail, and now I'm ready to perform an angiogram to assess whether there is any major paravalvular leak. And this is, we did all the steps like in reality, including predilatation. So there are no compromises. We didn't skip any step. This is the real-time implantation. The 3 commissural markers tell us the height of the valve, so we don't need to go too deep with the pigtail, otherwise we can interfere with the valve. And now we perform an injection. You see, the valve is implanted at the correct position. There is a really tiny paravalvular leak that is gonna disappear at the echo because the valve will continue to expand, being an nitinol device. And actually the implantation now is over. Next step would be to close the access. We don't need to post-dilate this valve, which is well expanded. It is not too deep, not too high. Actually, it's in a perfect position. And it's not needed to exchange for a different sheet. We can just remove this. Obviously, there is a pre-closing system if you have been using. If you use a different closure system like a Manta device or a Percosil device, you just keep the wire in and you put your closing system. I think this was a nice and complete demonstration on how Portico can be implanted with the FlexNav system within a human-grade simulator. You can really implant alone without need for any partner with the implantation, performing all the steps from A to Z of the procedure, exactly in the same setting that you have in a cath lab, using the same imaging, the same projection, the same pathophysiological condition. You can even personalize the valve. If you want to have a more calcific valve, you can use it. If you want to have a less calcific valve, you can use it. If you want to change the angulation of the aorta to challenge yourself with an horizontal anatomy, you can do it. So there are a lot of variables that you can do it. But most importantly now, you can start from the beginning and do it again, and again, and again, and again, until you are ready and you master all the procedural steps before moving to human. Thanks, Gustavo, for the invitation. Thanks for Valve TV for the invitation. And I hope you will enjoy the rest of the webinar.
I think we are all impressed with this.
Yes.
with this video.
I get to hear the class.
Yeah. So
Congrats, Mauricio. Fantastic presentation.
Yeah, I would like to hear from I would like to hear from Ilan and Mohammad, Adolfo, and João, your impressions from this video. How did you feel?
To the final comments, no?
I thought that it was really well delivered. I mean, you took it through, each one of the steps, the simulation, to have the nice 3D print of the valve decalcification, the resistance. It was really beautiful to see the fluoroscopy, the pigtail, non-coronary cast, and the deployment too. I was going to ask you, there are plans also to have the coronaries there for the simulation of coronary arteries and things like that. Actually, even for commissure alignment, as you have the capability to do that. I mean, that would be phenomenal. I'm sure that you're thinking already on that.
Yes, you can. Sure, you can you can do commissural alignments like in reality. You can even wire the coronary if you want. You can potentially also replicate anatomy with high risk for coronary occlusion and protect the coronary. You can actually do whatever you would do in reality. Absolutely, that's a good point.
Okay, thank you. Adolfo?
For me, it's astonishing. I would say that maybe proctors are not going to be anymore useful. Because if you can master this technique for doing it by 15 times or 20, then you are almost a master. I think that is the future. There's no doubt. The only thing is, of course, all the industries must need this type of simulator to train all the procedure. It's astonishing. I had the opportunity to work on this type of simulator, and I was always surprised. It's beautiful.
Fantastic. Mohammad?
Sure. I agree with everything that was said, but I have a question actually for the masterminds, you, Marcio, Andrea, and of course, Professor Maisano. This was truly fantastic. It was as real as it could be, but again, you actually need a real valve. You need a real delivery system. Do you think that in the next stages, or you're going to focus more on VR or AR, virtual reality or augmented reality, by which you may become potentially independent of having an actual device and you can actually deploy without having a real valve? Because that is going to add roughly about $30,000 or so. I don't know how much you buy it from the company. Probably early on, they're going to give it to you for free. But as time goes by and as the number of people who are going to ask for this simulator would rise, and at some point, how many times you can deploy a valve? Probably 20, 30, 40 times. But at some point, it's going to lose its structure. Do you have any plans for future?
Mohammad, but on the other hand, don't forget, this is going to be a standard step of the training from Abbott. And again, there's a huge difference between what you can achieve with a visual simulator and what you say augmented reality. I mean, maybe in the next future, augmented reality will replace everything. But I want you to think 1 second what you have seen in the cameras. When you have seen the height of implantation and how the sealing portion of the valve was fitting into the intercommissural triangles, and you then understand why if you miss the height, you don't get the sealing and so on. I mean, all these details can be only understood on a very sophisticated anatomical system, which helps you to understand the procedure. Now, there is no discussion that you also can have different tools to achieve the goal, but at this moment, there is nothing that can be as useful as this one. But I agree with you. The future is virtual, is augmented reality, and it's also there are also other things that are coming. Some hybrid solutions. You have seen that Simulands is also working on augmented reality to make the simulation more real in terms of scenario building, and so you will see there will be much more. I mean, in the next future, you will not see anymore the simulator. You will see a body, and you will see screens in front of you. So it's amazing what happens. We did already some tests.
That's fantastic.
So, if I may add a point and a question, actually, I'm an imager, right? And I've been working with 3D printing and virtual reality lately. 3D printing for 5 or 6 years in virtual reality, not augmented reality yet, but virtual reality for tumor excision planning and other applications. And I've been working with Tavi a lot, and what I see a lot is anatomical variants, right? So there's a lot of different valves, a lot of different scenarios, ventricles that are big, ventricles that are small, angles that are extremely different from one another, excesses, and etc. My question then, and also subvalvular calcification, which I think would complicate things a lot, right? And it's very unpredictable in the way it may affect the overall result. So my question is, can we move to a point in which we will print the actual heart of the patient that you're going to affect and simulate on the actual heart that you are going to put the valve in, and not only the Tavi, or you can print the left atrial appendage for a left atrial appendage closure, and you can print the tricuspid valve, and you can print the septum and for septal closures. Can you work with real models from the real patients that you're going to affect?
So, Ilan, let me answer like this. First of all, this is already state of the art. If you do a first in man, in most occasions, you will train yourself on a very patient-specific training model, where you will 3D print exactly the patient you are treating that day. Now, this I don't think is going to be a model that you can see in the future for every case. It doesn't make much sense. I believe there will be hybrid solutions. So first of all, imagine different things. You made good points. There are horizontal aorta, hypertrophic hearts, there are bicuspid, tricuspid. All these variants are already available in the Simulands platform. So you can train different scenarios in different anatomies, which are, let's say, clusters. We are not really implanting in a real.
All right, welcome back, everybody. Our next topic is.
Something happened, right?
Yeah, I think so. Pedro.
We lost Francesco, yes.
We lost Francesco?
I think so. That's his reason. Okay.
Yeah, just to complete what Francesco was saying, all these variants, anatomical variants and customization are available at the platform. One point, all our platforms are built based on input like yours, are built with from clinician for clinicians. So we encourage any input that can help in making this our platform more personalized for what the modern interventionally needs today and will need in the future.
Okay.
Very good.
Thank you, Andrea. João, do you want to say something? I think that. Okay. No. Okay. Thank you. Marcio, your last comments, please.
Yeah, just to add something to what Andrea said, always in line with what I said before, because I like this concept. The personalization and the customization of the simulation experience is really depending on which is the target of this specific training. If you want to learn or to teach procedural step for Portico, like in this case, obviously you can simulate horizontal aorta, you can simulate different anatomical scenario, but then you don't need the specific anatomy of the single patient. You don't need to print for every patient a heart. If you need to perform a first in man, like Francesco said before, actually in that case, you want to have the specific heart of this patient. You want to replicate that procedure. And the beauty is that you can do it. So it's really depending on which level of training and which is the specific training target of each time.
Okay, thank you. Francesco, before your last comments, I'd like to say that I don't believe that you will retire in 10 years. But let's hear you. Your last comment, please, Francesco.
Yeah, I think last comment is very simple. It's a pleasure to be here together, guys. And we are living in a virtual world with virtual meetings, simulated things. I am fed up of simulation. I hope we can meet together and have a real caipirinha all together. That's my final comment.
Great. Gustavo?
Guys, it's a real pleasure to have you all here. A great gift that you are giving to us from 4 Valves. And I wish you the best. And thanks a lot. I hope that we can meet again sooner. Okay?
Yeah.
Thanks a lot.
Congratulations.
Great.
Today, before the end, I'd like to send a big hug for all of our audience. And we have guys from Argentina, Sebastian Peralta, Marcelo Menendez, Brazil, Dinaldo, our friend Dinaldo, Pablo Tomé, Esteban.
From Chile.
Yes, Carlos Olivares from Chile, Ender, Christian from Ecuador, Alex Felix from Rio. So we have Carmen from Spain. So we have a lot of doctors from the whole world, and I think that was fantastic today. A great transmission, and we'll see you soon. The next transmission for Valves TV. Thank you very much. See you. Bye.
Thank you, guys.
Thank you very much. Bye.
Thank you, Francesco. Thank you.
Congratulations for once. Congratulations for 1 year birthday.
Happy birthday. Bye.
Happy.
Bye.